Welcome back. Okay, so we're going to take some more notes. All right, so we're almost done with this note template. All right, so here we're going to identify the measures of the arcs and whether it's a major arc, minor arc, or semicircle. I'm going to write below, and then you write in as much as you can. Have the at least write in the measurement and maybe some information that'll help you figure out how to find it when you're solving problems. All right, so let's start with number 16. Oops, there we go. That's close enough to a 16. All right, so that's CD, and CD is so notice here, it's right here, certainly less than 180 degrees, so that is a minor arc. I'll just write minor. I won't write the word arc. We know it's an arc. Actually, I'll write arc, but if it doesn't fit in your notes, you want to just write minor, that's fine. All right, so that's a minor arc. We want to find the measure of that. All right, well, it's going to be the exact same measure as its central angle. Right, so the central angle is angle CBD equals 55 degrees. And so angle arc CD is going to be the exact same measure, right? That's the central angle for that arc. So arc CD is also 55 degrees. Those are congruent to one another. Number 17. AC. Also a minor arc. And we want to find the measure. Well, notice it says right here that AD and CG are diameters, right? So this is a diameter going through here. I can't point to it. You can't see if I point. It doesn't really help you very much. I was thinking colors would pop up here, but they didn't. I wanted to switch colors. Here, I'll just write in black. All right, so this right here, that's a diameter, right? So from A to D is 180 degrees, right? And we know what CD, arc CD is, so we can subtract 180 degrees, 55 from 180 degrees, and we'll have the measure of arc AC. So arc AC is equal to 180 degrees, right? Because this is a semicircle, AD is a diameter, minus the measure of arc CD. All right, so that means that's just going to be 180 degrees minus 55 degrees, so that's going to be 125 degrees. Okay. That's all there is to that one. Number 18. CG starts at C and goes to G, and it really doesn't make a difference which way I go. All right, CG is a diameter, so we know that since CG is a diameter, this is going to be a semicircle. And its endpoints are on the diameter. And that means that arc CG is 180 degrees. Sometimes I write in the M for measure, and sometimes I just kind of leave it off. It's kind of understood. We're doing measures here. 19. Arc CGD. Right? So starts at C. I need more colors. I'm going to start repeating the colors. Goes through G and continues to D. Notice that's the entire circle except for CD. So that is certainly more than 180 degrees. This is a major arc. Okay. And so CGD is just equal to the whole circle minus arc CD. That's the only thing not included. So that's going to be 360 minus 55. So that's going to be 305 degrees. And now I'm back to using blue for number 20. Arc GCF. So starts at C, goes through G, whoops, oh, excuse me, that's not, it's GCF. By the time I started drawing it, I completely forgot what the arc was. Also couldn't figure out how I could go through G, C, then G, then F. If I went the other way, I could. I'm not going that way. But let's start at the right place. G, C, F. So I would have had to go the other way if it was CGF. But it's GCF. And so notice that's everything but that tiny little piece there, which I don't even know if you can see it anymore, is CF. So that one certainly is a major arc. That's a mighty major arc. It's almost in a whole circle there. And so arc GCF, I keep wanting it to be CGF. There's not even a CGF up here. Right? So arc GCF is equal to 360 degrees minus, that was arc CF that I've drawn all over, but you can see it in your notes. Maybe you didn't draw over yours as much as I did. 360 minus 35, because remember, the arcs equal the angles. Right? So if you know the angle, you know the arc. If you know the arc, you know the angle. And that's going to be 5 degrees. Moving right along to 21. Arc ACD. So starts at A, goes through C, and continues to D. Well, AD is a diameter. So it's got the endpoints on the diameter. That's a semicircle. Exact same thing as 18. Our endpoints are on the diameter. And so ACD equals 180 degrees. 22, 2 more to go. AG. AG is somewhere. I've drawn over this so many times now. I don't remember which one is G. I think it's that one hiding right here. I'm just going to look at your notes because I still have it in your notes. Yes, that is G. So let's label that G because I can no longer see that. That is G. So we want AG just from here to here. Right? One of the few angles that is not listed there, but that's okay. We can find it. Right? So let's see what is that we know. Well, we know, well, actually there's a couple ways we could find it. We could find the measure of arc AB. And notice that, not AB, excuse me, arc, you know, I got to do this. It's just too busy up here. Let's just get rid of this for now. Oh, look at that, we can see. All right, so a couple ways you can go about this one. Things we know. I don't know if we found arc AC. We did. So 17, this was 125 degrees. Right, we already found that one. Right, and so the angle inside is the exact same measure as the outside. So this is what we're looking for right there. So we see that from CG there is a diameter. We could just subtract 125 from 180. Let's do that. All right, well, that is a minor arc. This is not the only way we can solve it, but this is one way. So since we've already found AC, let's use this way. And then I'll show you another way because you'll see a relationship. All right, so it's a minor arc, and AG is equal to 180 degrees, half a circle, minus arc AC. And AC is 125 degrees. So that would be equal to 180 minus 125, which is 55 degrees. Hey, another arc is 55 degrees. Well, guess what? We have two intersecting diameters here. These end up being vertical angles as well. All right, so let's just write next to our diagram here. These are vertical angles, so they're going to be congruent. And we know they're vertical angles because they're formed, but that's really messy. They're formed by diameters. All right, so those would have to be, it's not like it's 3 lines, it's definitely 2 lines. Right? I'll try to write neater. Formed by diameters. Right? Both of those angles are formed by those 2 diameters. So those intersecting diameters. Oops. Right? So those are vertical angles. And the last one, this is it, 23. Arc ACF starts at A. Now I've written all over it again. Goes through C, continues all the way to F. Notice that's everything. This is 55 degrees, right? Everything but those 2 little arcs there, the 55 and the 35. That is a major arc. And ACF is going to be equal to 360 degrees, the whole circle, minus AG plus GF. So that's going to be 360, I should put parentheses around it because we're not subtracting one then adding the other, we're just adding and then subtracting the both of them. So 360 minus 55 plus 35, which is equal to 360 minus, I need more space. Well, I can squeeze it in there, I think. 90 degrees or 270 degrees. Yay. There we go. So together, those two must be a right, look at that, they're a right angle together. All right, so we solved all of these ones in your notes. We got a couple more, and then that's going to be it for us. And then I have some problems for you to solve out. All right, so if you have any questions, ask me in class. But I think this is the easiest of the angle relationships, just because the angle equals the arc. The others we have to do a little bit more work for. Here, except for the subtracting, we didn't have to do too much. So I put this one in, this slide in here. It's not in your notes, but I'm going to have you add just one little thing here. We'll just put a shorthand of this. So arc addition postulate. The measure of an arc formed by 2 adjacent arcs is the sum of the measure of the 2 arcs. Let's write that a little shorter. So in your notes, right? Arc addition postulate. We can add adjacent arcs, right? You can add those arcs together to make a bigger arc. All right, there's a nice little shorthand way, right? So you can add adjacent arcs to equal the larger arc, right? Equal the whole arc. And there you have a picture. Okay, so, and that's what we actually used in several of these problems. Everywhere we added the arcs together. So for instance, we use that, come on page, change, any day, any day. Okay, so when we wanted to find the measure of arc AF, we added arc AG and added GF together. A couple other places we added arcs, maybe that was the only place we added the arc together. We subtracted the arcs a whole lot. That may be the only place where we added the arcs. But you can always add 2 adjacent arcs to equal the whole thing. All right, so let's solve these two. And this one's in your notes. Given the label diagram with AB as the diameter, find the value of x. Right. So we know it's a central angle, and central angle equals arc. So let's write that. Central angle equals arc. Central angle equals the arc. Equals the intercepted arc. All right, so let's see which things angles and things we know. All right, we know this is 60 degrees, right? This is 60. I have no idea what this is. And I have no idea what this is. Okay? If you say 60 equals x minus 1, I will wonder how you came to that assumption. Just say, I'll just set some things equal to one another. They don't look equal. I got no reason to believe they're equal, but heck, let's just set them equal to one another and be done with it. Well, that would be wrong, right? We can only do things that we know to be true. There's no reason for those two arc angles to be equal, right? I can cut the pie up any way I want, right? No one says the pieces are the same. All right, so what do we know? We don't know those individual arcs other than that 60-degree here. That's not very helpful. But I do know I have a segment that goes through the center of the circle. Right here, AB. Right? Oops, come on. There it goes. All right, that's the diameter. So AB is a diameter. Oops. Arc AB is not a diameter. Segment AB is a diameter. So AB is a diameter. Therefore, a symbol for therefore, arc AB equals 180 degrees. So I know that if I add these two, let's put a letter in here so we can talk about it. Let's put a C right there. All right. So if we add AC plus CB, actually I should put it up here. That's going to equal 180 degrees. And you might be saying, but what about the other arc that's 60 degrees? Well, guess what? You didn't need that at all. That was just throwing you off. I gave you useless information. All right, so those two arcs together equal 180 degrees. AC is 3x plus 5, and CB is x minus 1, and together they're 180 degrees. So don't assume just because it's in a problem means you have to do something with it. Sometimes we have extra information that is just of no use to us. It's like, okay, that arc is 60 degrees, but who cares because it didn't help us solve the problem. All right, we add these together. We have 4x plus 4. All right, I just added the 3x and the x and the 5 and the negative 1, added like terms. Together, that's 180 degrees. We're going to subtract 4 from both sides. So that means 4x is 176 degrees. And now we're going to divide both sides by 4, which means that x is 44. Oh, I shouldn't say degrees. X is 44. If I plug it in, I'll have the number of degrees. X isn't necessarily correspond with anything other than a value, measure a value. All right, so x is 44. Let's check our work and see if it adds up to 180 degrees. We'll just plug it in. So x minus 1, that means this is 44 minus 1, or 43 degrees. 3x plus 5, that means this is 3 times 44 plus 5. 3 times 44, so 3 times 40 would be 120. And 3 times 4 is 12. So that's 132. And 132 plus 5 is 137. Okay. And 137 plus 43 degrees equals 180 degrees. It checks out, right? That's a diameter. That's got to be 180 degrees, half a circle. Right? So we're done with this one. Well, I didn't think this would take us this long. That's okay. You didn't have to do that much. You watched me, you listened to me, you watched me drop pens sometimes, or sit there wait for pages to turn. All right, so here's our last one. All right, we have a diagram here, and we want to find the value of x. All right, so sometimes when you have a problem like this, you can't go directly to solving what you're looking for. Sometimes you have to figure out all the things you know, and then decide on how you want to solve it. So for instance, I notice that this line goes from the center of the circle to the edge. And this line goes from the center of the circle to the edge. What do we call those? Those are radii. So this is a radius, and this one is a radius. And we know those have to be congruent to one another because all radii of a circle are congruent. If all the points on the circle are the same distance away from the center, then all the radii got to be the same length. So all radii of a circle are congruent. All right, so what else do we know? I know that this is a central angle. Let me switch colors here. Central angle, right? And I know that the central angle equals the arc. So if the arc is 70 degrees, this angle is 70 degrees. Right? Now we're getting somewhere. We've got a triangle. If you notice, we have a triangle. We have one measure in the triangle. We need more to find them, though. But I also remember that a triangle with two sides congruent is an isosceles triangle. And I also remember we learned something called base angle theorem. And base angle theorem said that angles opposite congruent sides in a triangle are congruent. Right? So now I think we know how to set this one up, because if this is x, this one's x, because those angles are opposite those congruent sides. So you see, everything you learn in geometry comes around again, and we build on it and build on it, right? And you learn more and more. So that means x plus 70 adds up to be a whole triangle there, 180. We can add those x's together, so we have 2x plus 70 equals 180. We can subtract 70 from both sides. That gives us 2x equals 110. And then if we divide both sides by 2, x is 55 degrees. And we have solved it. And it's just that easy. All right? So about 50 minutes it took us. I guess that's a class period plus. Right? And that's my last problem. Right? Last problem. So you may see some of these whiteboard problems as your classwork on this little mini quiz here. That's why I have it covered up. And in the next lesson, we're going to be learning about this problem coming up any day now, like maybe right now. So now our vertex is no longer at the center, it's on the edge of the circle. And what kind of relationship is there between the angle and the arc now? So just kind of glance here at my values, make a hypothesis, because in class on Monday, I'm going to ask you, what do you think of the relationship is? And I'm giving it away with the numbers. I'm giving it away. All right, see you in the next podcast. Thanks for watching. Or actually, I'll see you in class or in the next podcast. But there's no more podcast for this lesson. Bye for now.